Hello guys, welcome to my YouTube channel. So today we will see how to get procedural collision using matrices, and we'll get something like this. So it's purely procedural, so if we change our size of this geometry, it will still work this way, and if we just change our geometry also, then also it will work. So we'll see how to make this. So guys, let's see the quick theory about that. So suppose this red color box is our original box and we want to rotate it on this direction, which will look like something like the blue box. So we all know that, like, if it is a packed primitive, it will always rotate from its center, and if we want to calculate how much it's get rotated, what we can do, if we can get like how much we get rotated, that will be this angle. And if you check on this area, this will look like a right angle triangle, something like this. And now once we get this angle theta, suppose, so we all know that sine theta is equal to opposite angle upon hypotenuse. So theta's opposite side will be this one, and hypotenuse will be this one. So what will be the hypotenuse? Whatever our box length is, its half will be our hypotenuse from here to here. So this will be our hypotenuse, and we already knows that we can calculate it from the bounding box. And once we get the hypotenuse and we know like how much we are rotating this, then we can just get the sine of that angle, sine of theta, multiply by hypotenuse. Then we can get like how much offset we need on the y direction, that will be our opposite side, this one. So we'll just implement this formula in Houdini. So let's start. So I have a empty Houdini session. So first we'll take a geo node, then we'll take a box. I'll just quickly set some things up on this, just to set this on grid. And then we just need to assemble it, pack primitive, and then we will use a point warp. Inside the point warp, first we will need to rotate it. First we will take a rotate node. Rotate will give us a 4x4 matrix, which can be used for the rotation, but as this is a packed primitive, and to rotate this we need to convert this to a 3x3 matrix. So we'll just convert this to this way, and then we need to set the transform attribute from prim intrinsic. So we'll quickly set this up. That will be a intrinsic attribute, and the attribute name is transform, and this will be connected to our point number or primitive number. It will be the same for the packed primitive. And now if we just rotate it, it will start rotate. Now we just want to rotate it on this z axis, and now you can see like we can rotate it. But the problem is, if we check it with the grid, and if we see this, whatever rotation we get, it's going inside that grid, and we want this to calculate the proper geometry shape and give us a fake collision. So for that, what we will do, first we need to extract like how much rotation it is doing. So for that we have an option of extract transform, and extract transform will require a matrix 4. Then it will give us that matrix transformation value, rotation value and scale value. But right now we just need the rotation value, so we will just extract it. And as we know, like this rotation value will be in degree, so we will just convert this to radian. So now we have this values in radian. Now we'll use a trigonometry node to get the sine function of this. Just change it to sine, and now we have the sine function of this angle. Now the second thing what we need is the bounding box of this object. So for that we have bounding box node. Just have to give this as an input, and we need to calculate the length, breadth and height of this geometry. So what we can do for that is we can just subtract maximum from the minimum value, and so this will be our, you can check it here. So if you want to check it, you can just press X and click on this, so it will give you a visualizer node. So as you can see, it's X minimum, Y minimum and Z. I mean X, Y and Z values of his bound. So if you check it here, it is 1, 0.1 and 1. So it's approximately same. So we can just delete this node. This is our subtract node, and yeah, so now as we know, like this, if this full is our radius, then if this full geometry is our diameter, then for the radius we need to just multiply it with the 0.5. So we can use multiply constant with 0.5. So now we have half of its length, and then we can just multiply this with the trigonometry function, and now we just have to do vector to float and float to vector. So now two things what we know is all the transformation will be on the y direction only. So we need to add x offset and y offset, sorry, x offset and z offset, and just need to add it in the y direction. And as our offset will always be positive, then what we will do is we will just put absolute and just put another absolute, so that it will also always give us positive result. And then this is good, and then we just need to add it with the position. Add it to position. So now if we see, if we rotate it, it will get up, and now we can use a sine function to automate it. Angle, time, and we can use a fit just to control how much we want to move it. So sine function will give us from -1 to 1, and we want it to be -0.25 to 0.25. So you can So now we can just multiply this, multiply constant we can use, yeah, we can multiply constant with 10, I guess. Yeah, so now you can see your geometry is getting the collision. Yep, so now I want to add one more thing on this. So if we see here, we are rotating this here, so we are rotating this on z axis, and if we just check the rotation values, just press X and just visualize it, then you can see like it will only give us values on the z direction. So what will happen because of that, if you just change the size of this, suppose 2, and if you now check it, it will get, if you can see the penetration again. So to fix it, what we have to do is we have to swap the axis, because if you are rotating in z axis, you will rotate your object will rotate on the x axis. I think it may be a bit confused. So what we have to do is just to do float and float to vector. So we have to give x to z and z to x. So this small thing will fix this problem. So now if you see, we are rotating this on the z direction, but the points are going like rotating on the x direction. See, x, this is our x direction, and the rotation axis will be z, but the all the points are rotating on the x direction this way. So that's why we did this, and now it will work. You can change the shape any which way you want, it will work fine. So that's it. It's a quite simple thing. It may be like bit complicated for some of you guys, so you can ask me anything anytime. You can just put it on comment and I'll reply as soon as I'll read it. And I just want to show you some quick test which I had done. So yeah, so here you can see I have same like some boxes which are of different shape and sizes. I just time offset it in the static frame, and now as I have multiple objects, so now I have to calculate the bound of that. So for that we have a very nice attribute called packed bound in prim intrinsic, which can be used like in many ways. So for now what I have used it for to calculate the bound and just get the length, breadth and height of that object. So I have did this, and I have just deleted all the geometries. So for this, just one addition is I have to do all those things, but I already have some rotation which is saved in my orientation. So I have to take that as a base and then have to add the rotation on it. So for that what I have done is I have just imported the orient attribute, then I converted into a matrix, then I put that matrix into a rotation, and also converted that matrix. I also extracted the rotation from that matrix. So this is my new rotation, and this was my old rotation. So what I am doing is I am just subtracting the old rotation. Old rotation means whatever rotation I am getting from the DOP, I am just subtracting it from the original from my rotation, so that I can just get the exact rotation value how much I want to rotate, and from with that value only I will just push offset my object in the y direction. Otherwise it will offset the object in y direction calculating this rotation plus this rotation, which will be wrong. So that's why I am just subtracting the rotation, so that I can get only the new rotation which whatever I am getting, and then the same thing degree to rotation, then I am just calculating the sin theta of that, and then again multiply it. And for the bounding box also I have already calculated the length, breadth and height. So I already have a vector called b box which I had made it in this triangle node. So I am using that directly. So now this is fine, this is same, and just adding it into the position. And for this one, like right now I just have the points and I don't have the prim intrinsic matrix for this, so I have to update the orient attribute for that. So once I'll update the orient attribute, you can visualize it like this. So this is your original orientation attribute, and after tweaking it you will get this. So you can see all the boxes are rotating, and now if you put it in the transform paces, you will get the updated orientation, and you can check it with the grid. So you can use it like in many ways. So I would love to see if you guys will try something with this, and you can anytime ask me, as I said earlier also, if you need anything, and if I'm confusing you in something, you can anytime ping me or put something on the comment. Thank you guys.